Okay class, today we're going to learn about the Polygon angle sum theorem. Our essential question is, how can the relationships between geometric figures be used to solve problems? Notice we have examples and non-examples of polygons. So based on the picture, the definition of a polygon is a closed plane figure formed by three or more segments with no overlaps or crisscross. So number one says, determine whether each figure is a polygon. Number A is yes. It has 7 sides, so a 7-sided polygon is called a heptagon. B is no. Remember, a polygon is formed by segments, so it shouldn't have any curves. C is yes. Notice it's a polygon with 6 sides, so it is a hexagon. D is no. We cannot have any crisscross. E is yes. A 4-sided polygon is called a quadrilateral. 5 is yes. A 5-sided polygon is called a pentagon. And G is no. Remember, a polygon is formed by segments, so it should not have any curves. Now we're going to study the example of a concave polygon and a convex polygon and make a definition of each. So a concave polygon, notice part of the picture caves in. So it is a polygon with at least one diagonal outside the polygon. And a convex polygon does not cave in. It is a polygon with all diagonals inside the polygon. Now we're going to look at the 4 examples of a regular polygon and create a definition. So a regular polygon is a polygon that is both equilateral. Recall, equilateral means that all sides are congruent, and equiangular. Remember, equiangular means all angles are congruent. So notice in the picture, the tick marks show that the sides are congruent, and the arc marks show that the angles are congruent. You should notice that all regular polygons are convex polygons. Now example 2 says, state whether each polygon is regular or irregular, and if it is concave or convex. Recall that a regular polygon is equilateral and equiangular, meaning all sides are congruent and all angles are congruent. So in example A, this is irregular because our angles, we have one set of arc mark and 2 sets of arc marks. So that means the angles are not all congruent. And this is a convex polygon because notice we can draw all the diagonals on the inside of the polygon. Notice nowhere in the picture is the polygon caving in. B is also an irregular polygon because notice the tick marks. Some sides have 1 tick mark and some sides have 2 tick marks. So that means not all the sides are congruent. And it's concave because part of the polygon is caving in, meaning we can draw at least one diagonal outside the polygon. In example C, it is a regular polygon. Notice by the tick marks. All the sides are congruent, and notice about the arc marks. All the angles are congruent. And it is also a convex polygon. It does not cave in, and we can draw all the diagonals on the inside of the polygon. Recall from our warm-up that a 3-sided polygon is called a triangle. A 4-sided polygon is called a quadrilateral. A 5-sided polygon is called a pentagon. A 6-sided quadrilateral is called a hexagon. A 7-sided quadrilateral is called a heptagon. An 8-sided quadrilateral is called an octagon. A 9-sided quadrilateral is called a nonagon. A 10-sided quadrilateral is called a decagon. The way I remember decagon is I think of you're a decade old, you're 10 years old, so decagon has 10 sides. And a 12-sided quadrilateral is called a dodecagon. The way I remember that, I think of do, I think of English 2, and then decagon, decade, 10, so 2 plus 10 makes 12. So it is a 12-sided polygon. Chart 2 says draw all possible diagonals from one vertex in each polygon below, then complete the chart. Recall a triangle has 3 sides, a quadrilateral has 4 sides, a pentagon has 5 sides, a hexagon has 6 sides, a heptagon has 7 sides, and an n-gon has n sides. So a triangle, that would be one triangle. But look, if we draw a vertex with one of the quadrilaterals and draw a diagonal, notice it makes 2 triangles. For a pentagon, if we draw diagonals from one vertex, notice it creates 3 triangles. A hexagon, if we draw a diagonal from one vertex, notice we have 4 triangles. And a heptagon, if we draw a diagonal from one vertex, we have 5 triangles. Notice the pattern between the number of sides and the number of triangles. The number of sides is always n minus 2. The number of triangles is always n minus 2. Now we're going to figure out the sum of the interior angles. Of a triangle we learned is 180 degrees. A quadrilateral has 2 triangles, so 180 plus 180 is 360 degrees. A pentagon is 180 plus 180 plus 180, which is 540 degrees. A hexagon is 180 plus 180 plus 180 plus 180, which is 720 degrees. And a heptagon is 180 plus 180 plus 180 plus 180 plus 180, so 900 degrees. So the relationship between the number of triangles and the sum of the interior angles of a triangle is n minus 2 times 180. So to summarize what we learned, the formula for the interior angles of a triangle will be interior sum is n minus 2 times 180, where n stands for the number of sides. Now, to find the measure of each interior angle of a regular polygon, If it was a triangle, you do 180 divided by 3. If it's a quadrilateral, you do 360 divided by 4. If it's a pentagon, you do 540 divided by 5. If it's a hexagon, you do 720 divided by 6. If it's a heptagon, you do 900 divided by 7. So, to find each interior angle of a polygon, you just do the sum of the interior angles, which is n minus 2 divided by 180, divided by the number of sides, which is n. So let's apply these two formulas. Number 3 says, find the sum of the interior angles of a convex nonagon. Recall, a nonagon has 9 sides. And our formula for the interior sum will be n minus 2 times 180. So we're going to do 9 minus 2 times 180. 9 minus 2 is 7, and 7 times 180 is 1,260. So the sum of the interior angles of a convex nonagon is 1,260 degrees. Example 4 says, find the measure of each interior angle of a regular decagon. Remember, a decagon has 10 sides. A good way to remember is you're a decade old, you're 10 years old. So a decagon has 10 sides. The formula for each interior angle is n minus 2 times 180 divided by the number of sides. So we're going to do 10 minus 2 times 180 divided by 10. 10 minus 2 is 8. And 8 times 180 is 1,440. And 1,440 is 144. So the measure of each interior angle of a regular decagon is 144 degrees. Number 5 says, find the measure of angle BCD. So we're looking for this angle right here. Before we can find the angle, we got to find the sum of the interior angles. Recall there's two ways. You can just use one vertex and split the figure into triangles. The sum of the angles of one triangle is 180. Since we have 3 triangles, it is 180 plus 180 plus 180, which is 540. That's one way to find the sum of the interior angles. The other way is to use the formula. The interior sum formula is n minus 2 times 180. Notice this is a 5-sided figure, so n is 5. So 5 minus 2 times 180. 5 minus 2 is 3, and 3 times 180 is 540. So notice the sum of the interior angles is 540, no matter what method you use. So we first need to find x before we can find the measure of angle BCD. So that means 18x plus 32x plus 35x plus 18x plus 32x has to equal 540 degrees. So now we're going to combine like terms. When we add the x's, we get 135x equals 540. Divide by 135, 540 divided by 135 is 4. Now to get the measure of angle BCD, in the spot of x, we're going to substitute 4. So 35 times 4 is 140 degrees. So the measure of angle BCD is 140 degrees. Number 6 says, name the convex polygon that has a sum of the interior angles of 1080. Notice we have to work backwards. They gave us the interior sum. So the interior sum formula is n minus 2 times 180. So in the spot of the sum, we're going to substitute 1080. So the opposite of multiplying by 180 is dividing by 180. 1080 divided by 180 is 6. Opposite of subtracting 2 is adding 2. So 6 plus 2 is 8. And an 8-sided figure is called an octagon. Recall the exploration we did on Math Open Reference that the sum of the interior angles of a polygon, no matter how many sides it is 360 degrees. So exterior sum equals 360 degrees. Now, just like we did the interior angles, to find the exterior angles, you do the same thing. So you do 360 divided by the number of sides. So each exterior angle is 360 divided by n. So let's apply these two rules. And my eraser doesn't want to work very well today. Okay, it says, example 7, find the measure of each exterior angle of a regular dodecagon. We learned that a dodecagon has 12 sides. Remember, think of do as 2 in English, and decagon as decade, 10 years, so 2 plus 10 is 12. So dodecagon has 12 sides. So we're going to use the formula that each exterior angle equals 360 divided by the number of sides. So 360 divided by 12 is 30 degrees. So the measure of each exterior angle of a regular dodecagon is 30 degrees. Number 8 says find the value of x. Notice all these angles are exterior angles. We learned that no matter how many sides the polygon has, the exterior sum is 360 degrees. So we're going to add up all the exterior angles until we get 360 degrees. So 16x plus 10x plus 28x plus 15x plus 18x plus 33x all has to equal 360 degrees. So when we combine like terms, we get 120x equals 360 degrees. Divide by 120 by both sides. 360 divided by 120 is 3. So x equals 3. Number 9 says, find the number of sides of a regular polygon if each exterior angle has a sum of 120 degrees. We learned that each exterior angle equals 360 divided by the number of sides. They gave us the exterior angle is 120. So that's 120 equals 360 divided by n. And then we can cross multiply. 120 times n is 120n. 1 times 360 is 360. And 360 divided by 120 is 3. So the number of sides is 3. Some of you might have noticed a shortcut. All you had to do was just do 360 divided by 120 is 3. And then you didn't even have to cross multiply if you noticed that shortcut. Play this video over and over again to help you work on your online homework.